There we go. Okay. So 21. As you guys can read, a 1 kilogram firecracker at rest splits into 2 pieces. Piece 1 has a mass of 0.25, and piece 2 moves with a velocity of 12 meters per second to the right. Okay. First question says, what is the mass of the second piece? Okay. So, when looking at this, my paper is really dirty. All right, when looking at this, our equation is the same equation. Oh gosh, same equation we've been dealing with. Okay, momentum initial equals momentum final. Okay, where my mass of object 1 plus the mass of object 2 times my initial velocity. Right, because in an explosion, now when it explodes, well, they separate. So mass of object 1 velocity final plus mass of object 2 velocity final. Okay. I guess technically I'm answering number 2 right now.
I was about to say, you're making this a lot harder than it has.
Yeah, number 1's straightforward. That's just 0.75. You just gotta subtract it. All right. That gives us the mass of number 2. Okay. So mass of 0.25, mass of 2 is 0.75 times my initial velocity. Does that make sense where I got mass 2? Just double checking. Okay. Equals mass 1, 0.25, velocity final, and then mass of 0.2 is 0.75. Velocity final, that is 12 meters per second to the right. Okay. And that's how you would solve that type of problem. Okay. What did you get for your answer for the velocity? Negative 36 meters per second. That's how you solve that type of problem. Okay? That's how you solve. What's the initial and final? 0. Perfect. Right? That's pretty easy, yeah.
Okay, this is a little bit off topic, but I asked every single one of my teachers this.
Does it involve grilled cheese?
No. So if you had unlimited money and your job could take you anywhere you wanted, where would you want to live?
Where would I live?
Anywhere in the world, yeah.
North Korea.
Do you want my honest answer or like my dream? Well, not my dream. My fantasy, I should say.
Fantasy, why not?
Fantasy? My fantasy, if I could move anywhere in the world and I had a ton of money.
Ton of money. You can keep this job, you know. Or do something else.
I would want man. I'd probably go to either.
I can see you living in like Brazil.
I would probably go to England.
Okay.
Like London, or are you talking like what's the Dover?
You want a specific city in
He's getting a
England?
castle.
Yeah, why not?
I don't know. I'd have to research that. My reality answer would be here.
That's boring.
It is boring, but
That's so nice.
I'm a big family guy.
There are
Love
like
my family.
castles.
I wouldn't want to move away from them.
You have kids?
No.
They're like
He has a dog.
You just leave.
Yeah, he's
Just leave his
leave behind.
Whoa.
No.
Pursuit of blonde.
Make me cold.
So
She's
anyway,
still young. My mom was young when she had me. I don't know.
all right. Let's see. Oh, you didn't see that. It's got work.
Exactly.
Yeah.
Oh.
We're stepping up our game here. Hey, I'll take a victory. We can still see it.
Just sit there.
You should have worn the safety belt.
Did it break the window? That's not-
My computer's going
Absolutely whacked in my head. That's quite a idea.
I loved his eyebrow. That's just-
How is he staying so still?
Yeah.
I love watching things in slow mo. Honestly, super cool. Especially watching light stuff.
Does this remind you guys of the dude from Bears and the one crazy dude on TikTok? You know what I'm talking about?
Okay,
The one with the bell.
so
No, like the crazy dude.
thinking of this video, notice how the watermelon explodes. Explain how momentum is conserved. How's momentum conserved in that? Jake?
It's 0.5.
Okay.
It's 0.3.
How's it? So we understand momentum. The velocity is zero here, so that's why we know it's zero. But hopefully we're getting the concept that the momentum final, it goes in all different directions, right? The easy way to look at it is when there's two vectors and they just go in opposite directions. All right, if it's the same mass, all right, and that's how.
Wait. So like, this is overcomplicating it, but if it's sitting on a table, like so say the watermelon, the vector of the pieces go up this way, but the vector of the bottom is stopped.
True.
So like, momentum is not fully conserved. Technically. Maybe I'm wrong.
The best way to.
That's why.
I love the question. So you got explode and everything. The best way I can explain that is so those two will cancel, those two will cancel. The x's in this direction will cancel, but we still have the y's. It's still shooting down, you just can't see it. Okay. Like yes, it's not going through the table, but there is still matter that are like that's hitting the table.
Okay.
It's kind of hard to explain, but yeah.
Okay, I'm just curious.
Yeah.
We know that like momentum from the beginning to the end is consistent, but
Yep.
does it fluctuate in the middle? Like, do the numbers does it stay consistent all the way through, or does it kind of like?
Because at the beginning, like, say if it was like one mass, but like the explosion wasn't in the dead center, so like
Yeah, because the velocity changes.
the initial velocity would be different, I feel like.
In theory, it would stay conservative.
Okay.
Like say the explosion was to the far right of the watermelon.
I think it has eyes.
So it's way over here. So they,
No, like it's still inside the watermelon, but to the far right, like right there. So would that side experience a different velocity than the left?
yes. Based on the surface area. And that's drawing a whole new,
And then, okay, so it's,
that's adding up
Getting
a
it to me.
whole new chapter.
so you're telling us that we will be able to figure this out? Possibly. in the
That?
future? Yes.
Not in my class.
Okay.
Unless you take, that would, oh, I got an answer for you, by the way.
Oh.
So he's actually going to come in our class and talk tomorrow. Mr. Corzan, he's the guy that teaches AP2, C mechanics, and C electricity and magnetism. So he teaches all 4 of those. He's going to be coming in talking about different ones based on what interest you guys have for after this class, right?
Going to college.
To do what is the question?
Biology.
Say what?
Biology.
Biology.
No, I have no idea why.
There you go. I was like, you're not going to be using too much physics? Honestly, this might be the most physics you are going to use. So just going to talk about different courses like AP Physics 1, you can take AP Physics 2, or you could take AP Physics C Mechanics.
Go juniors.
Okay? You can take either one of those where AP Physics C Mechanics is the same topics we went over this year. The exact same, but calculus based.
Oh.
It's not bad.
Let's go.
It's not bad. Same topics, just calculus. Okay? Where you're going to do more derivatives and integrals.
Taking
I don't even know what derivative is.
Okay? Just saying.
Those are some solid calculus.
Yeah.
Oh, see, I'm not doing that, I'm just taking.
Where we just derive equations. All right? So he is going to come in tomorrow. Just chit chat for a minute. See what you guys are thinking. All right. He suggested not to take AP Physics C, electricity, and
Today's National
magnetism.
Day.
Can't think about that. Magnetism.
I didn't
Don't
even
take
know
that without taking.
I probably wasn't even
He
here.
suggested taking AP Physics 2 before
I
that.
was here? No, I was
You
here.
commented on it too.
Oh, wait.
That makes sense.
That's a
Oh, because it's budget. You need to take.
When? What did I say?
All right, but you can ask him most definitely.
I never said that.
All right. Next question.
If I
All right.
would've said that, I would remember.
You'd be surprised. Try this problem on your own. All right. I feel like we're doing pretty good on explosions. Try this on your own. I believe in you guys. Okay.
Where's the bridge?
That's a seriously small bowling ball.
It's like one of those kid bowling balls, kiddie ones.
Yeah, those are still
They go down to 6. This is technically like 4.
I forgot about that. I went to a garage sale.
It's 3.7.
That's a typo in there. Well, this is just an outrage. Person.
No, I did this wrong.
Does yours actually say west?
Yeah.
Yeah.
Hot dog.
Let's hope I did this right.
Don't look, don't look, don't look, don't look. There we go. I didn't see it. You didn't see anything. Okay.
I got west. If you're doing it west, negative 18 and bowling. Oh wait.
You can still have 18 as long as you have the direction west.
Oh yeah, that's right.
Because if you're throwing it negative 18 meters per second west, you're actually throwing it. So what?
I have to pay more attention because I gotta read west. Which I didn't do the first time.
All right. So when checking this problem out, okay, when checking this problem out. So if you throw it west, the skateboarder is going to go the opposite direction, right? Skateboarder is going to go east. Now, with what velocity? So once again, my initial momentum, final momentum. What's my? Do I have to write it all out? I feel like we got it. I think we got that. We understand that. All right. So we know the mass of the skateboard versus the velocity final of the skateboard, plus the mass of the bowling ball, final velocity in the bowling ball.
Brick.
Man, I'm really bummed about that. I'm so confused.
Why is
Alright.
he throwing it?
So let's see.
Skateboards.
For the most, I have to do a shot.
So let's see. 57 plus
Actually, that's be like that.
2.1 holds a brick. Initially, the rest of the person throws the brick. Okay. So the mass of the skateboard and the skateboarder was 59.1. Okay. We don't know the final velocity plus the mass of the brick.
Why is he throwing the brick and why is he on the skateboard while doing it?
So I was watching this show last night. It's called The Wall, and the question was.
Wait, hole in the wall?
No, it was called The Wall.
Oh, okay.
Oh yeah, I make a lot of.
Iron, ornament, cat litter.
Good question.
I can't answer another one of the riddles.
Paint can.
Yeah.
Oh, I know. Dang. No, one of those is not the same.
Yeah.
So
Those are all Home Alone shows, except for the.
there's a movie called Home Alone.
Oh.
Which one of these did the Kevin?
Yeah.
Kevin. Which one of these did Kevin not use?
It's not even Christmas.
There you go. Anyway.
Wait, how does that relate to?
Yeah. What was your question?
My question is, what is he doing on a skateboard throwing a brick 18 meters per second length?
Well, so when you said throwing a brick in Home Alone, the guy throws bricks at his eye.
That's why I was
So he throws bricks at him, so that made me think of Home Alone, and that made me think of yesterday.
I was so confused. I was like, what is the point of this?
That's my bad.
There's some
There's
some science that is
I've never seen
somebody would die.
You are very different.
All right, let's bring it back.
From that one.
What's the final velocity?
0.518.
Yeah.
Wouldn't it be 366? Oh wait, no, it wouldn't. Never mind. I got.
Hey, remember.
I'm sorry.
All right. Any questions on that problem? We feeling good?
Yes.
I like, this is
This
easy.
is pretty easy.
All right. You guys want one more?
No,
Yes,
maybe, why not? Yeah.
What one?
What are we gonna do if we don't?
Can we do a cannon one? I wanna see.
Another cannon?
I wanna see the.
Yeah. Oh, that's a rocket.
What? It's 23. Yeah, there it is. Yep. There's the cannon.
Why?
Oh, it's on wheels this time.
I'm gonna draw a cannon that has wheels.
They didn't answer it?
We should do it.
Now, this one's a little trickier. The cannon and the ball are initially moving forward with a speed of 1.27 meters per second.
It's not.
Okay. The cannon is ignited and launches a 0.0527 kilogram ball forward with a speed of 75 meters per second. Determine the post-explosion velocity of the cannon.
You knew that up there.
Mine? I was just gonna pull off the question. Okay, my cannon looked like that.
What?
What?
The green part was like
My
my
cannon
size
looked
big.
exactly like that yesterday.
That's not a cannon.
It's like a weird, like a sideways.
Yeah, it looks like
it's
it's
a
black.
Yeah.
It did look like
Yeah.
that. Now, what real cannon was it?
I'm not sure. I have a very limited canon experience, so they could look like that.
This is tricky.
Yeah, it's not.
But also I don't want my calculator died, so.
Same,
My calculator died in pre-calc.
and my computer. I'm having a
It was just God's way of telling me he does not want me to do pre-calculus.
Yeah, I need more.
Yeah, see, show him that. Go show him that. Show him that cannon.
16,000.
Cannon don't got nothing on mine.
Did you just look up?
Wait, what was
I gotta admit, that looks pretty good.
That looks like the dude from Doodle Jump.
It does. It does.
Okay, so once again, looking at this equation, once again, if we look at the mass of the cannon, we'll say that's 3.5. Mass of the ball that is loaded, 0.0527. This time, we have an initial velocity. The initial velocity is 1.27.
No, it's just equal.
Okay, is equal to mass of object one, the cannon, times the final velocity, which we don't know, plus the mass of the cannon
Wait.
ball.
Wait, we know the final velocity of, oh wait, wrong one. Mine is in a different order. I was thinking of my order.
So that's what we would do. You're solving for velocity final.
I didn't do.
Why did you make only one like fancy 7? None of our other 7s are just like
Normally I draw a dash in my 7s. Normally.
It seems like normally you don't though.
For 3 out of the 4, I did not do that. You're all right. All right, velocity
Yeah,
final. What did
seriously.
you guys get?
Yeah.
-1.159.
1.59. So 2 6 figs would be negative 1.6.
No.
Dylan?
0.16.
Oh, what?
I got
Not
0.16.
Yeah.
Oh, he did recover from that.
No,
There we go.
Physics.
Okay.
In a nutshell.
I feel like we're good on explosions.
All right. Can we watch Mark Rover?
All right.
Are we not taking into account the black powder that was burned?
Nope.
Because it wasn't, this isn't that kind of thing.
Wasn't that
It's
type
an
of
air
thing.
cannon, Dylan.
That's still air.
All right.
Air doesn't